All right, here's your homework for a geometric series. So find the indicated sum for each geometric series. So let's go and understand again the parts we need to know of the series to do the sum. So there's the formula. We do need to know the first term. That is 7. We need to know the common ratio. So what am I multiplying every time? So you can take 2 and divide them. They're consecutive, or see it, and it's -2, and the sign matters. And then how many terms are there? There's 8. So here's the setup. The sum of the first 8 terms in geometric. Nice long fraction line. And then it's A1, which is 7, and you go 1 subtract R. You got to put parentheses around -2 to the exponent 8. How many terms you have. And then the denominator is the same thing without the exponent 8. So 1 subtract -2. Then put it in your calculator, and you get the answer -595. And I know putting in the calculator could be a challenge. Let me just look at it quick with this 89 so you know how I typed it in. I won't do this every time. So if I was going to type that in, I'd first start with a parentheses before anything else. Then it's going to be 7 times 1 subtract -1, or negative, and this needs parentheses, -2 to the exponent 8, and then you close it, and then close it again, divided by, and then it's 1 subtract -2. 3 also works, right? But 1 subtract a -2, and your answer. So be careful of your parentheses. Really just look at it, press pause, make sure you know how to type it in. And when you press enter, notice how the picture is matching what you wrote down. That's important. If this picture doesn't match, then you typed it in incorrectly. All right, I'm not going to do that every time. I just wanted to show you once in terms of how to type it in your calculator. All right, let's get right to it. So, sum of the first 10 terms. Big fraction line. The first term is 12.8. 1 subtract. What am I multiplying every time to get it? So if you can't see it, I'm not going to use a decimal. I'm going to take any 2 consecutive numbers. So 20 over 16 totally works. I can reduce it down, divide by 4. So it's 5/4 is the R. So it's 5 over 4, put parentheses around it, to the exponent 10. And then the denominator is 5 over 4. Again, put parentheses around it, and then put it in your calculator. If you did it correctly, you get a fraction. I'll show you in terms of the decimal too, but it's 309,458 over 915. So if you just pressed enter, that's what it would be. If you go diamond enter, you'd have a decimal from there. All right, number 3. This one, you're not given how many terms there are. So instead, the last term is 78,125. I need to know how many terms it is. A1 is 5, and then it's R to the n-1. And we know R is 5, so let's put that in. Times 5 every time. n-1. So there's the setup. I need to solve that. So I'm going to divide by 5. 15,625. You can also get, I think, common bases right out. You could also type it in and solve it with your calculator, since you have one. What would the base be? It would be 5 to the exponent, I think it's 8. No. How about 7? Nope. How about 6? I'm going to get this. Nailed it. 6. So 5 to the exponent 6. 5 to the exponent n-1. So let the exponents equal each other. So n equals 7. Now, finally, I can set this up. So what's the sum of the first 7 terms? Big fraction line. Our first term is 5. Then 1 subtract 5 to the exponent 7 all over 1 subtract 5. That's it. And the answer is 97,655. Number 4. Another one where we're going to have to solve it. This time I'm going to show you in the calculator how you can solve it. So the last term is 25 over 16, A1, and then it's R, which we don't know, but we can find. So R, if I take 400 over 1600, that's a quarter. So R is a quarter to the exponent n minus 1. I'm going to use my calculator to solve this. So to type it in your calculator, you go F2 and solve, and you type in 25 over 16 equals 6400 parentheses 1 quarter to the exponent. Now I need parentheses, and I'm going to use x, so x subtract 1, and then go comma x, and then close the parentheses. So if you solve it, n is equal to 7 again. So again, press pause if you need to so you can see how I typed it in to solve that equation. And then you have the answer. So there's 7 terms. Now you can set it up. So the sum of the first 7 terms, a healthy fraction line. A1 is 6400. And then 1 subtract the ratio, which is 1 quarter, to the exponent 7. Again, put parentheses around that fraction. And then the denominator is 1 subtract a quarter. And again, put parentheses around that. And then type it in your calculator. So if you go diamond enter, so as a decimal, it'd be 8,532.8175. Let's see. There we go. We're back on the screen again. All right. Number 5, how about sigma notation? How do you know that this is geometric and if it's exponential? So do you see a base to that linear exponent? Then you know it is geometric. So from this sigma notation, I need to know the first term. So I'm going to plug in 1. So 1 take away 1 is 0. Negative 3 to the 0 is 1. And 5 times 1 is 5. So I'm going to know that we have 8 terms. The base is my R. So we start with a healthy fraction line, A1, 1 subtract, and it's negative 3 to the exponent 8, and then the denominator is 1 subtract negative 3. And then type it in your calculator and get negative 8,200. Let's do it again. Plug in 1. 1 take away 1 is 0. That's anything to the 0 is 1, and 1 times negative 80 is negative 80. So we're off and running now. We have 14 terms. So it's negative 80, 1 subtract, put parentheses around it, negative 1/2. So the base is your R. And then we have 14 terms. Close it. And then the denominator is 1 subtract negative 1/2. There it is. Careful how you type it in. Practice. The fraction would be 27,305 over 512. Number 7. So plug in 1 and you get negative 3. So the sum of the first 11 terms would start with negative 3. And then 1 subtract 4 to the exponent 11. And then the denominator is 1 subtract 4. Big healthy number, negative 4,194,303. So quite a small number, a negative 4 million and some. Number 8. So step 1 is to plug in 1. That gives me 512. So the sum of the first 7 terms would be 512. 1 subtract 3/4 is my R, to the exponent 7, and then 1 subtract 3/4 in the denominator. Make sure you put parentheses around this when you use a calculator, and as a decimal, it's 1,774.625. Number 9. Recognize here that you're starting with 4 that you're plugging in. So the first term is found using 4, so that's negative 3/8, 2 to the exponent 4 subtract 1. So 2 cubed is 8, and the 8's divide out, so you're just left with negative 3. Now we can set this up. So from 4 to 12 is actually 9 terms. You subtract and add 1. So a big fraction line, A1 is negative 3. 1 subtract. The base is my r, which is 2, to the exponent 9. And then 1 subtract 2 in the denominator. So negative 1,533. Here we're going to plug in 3 to find the first term. So when I plug in 3, I have 2,700 and then 1/3 squared. So 2,700 times 1/9. So that gives me the answer negative 3. No, what does it give me? Sorry, it gives me the answer 300. Then, to find the sum, from 10 to 3 is 7, so add 1, so it's 8. Fraction line. So we start with 300. 1 subtract. The r is 1/3 to the exponent 8. And then the denominator is 1 subtract 1/3. So put that in your calculator as a fraction, 328,000 over 729. Number 11. Determine if the series is convergent or divergent. If it's convergent, then find the sum. So for these situations, we want to know if the r is between 0 and 1 or not. So the absolute value of r, is it less than 1? If that's true, then it is convergent. If it's not, it is divergent. So what is the r in this case? Negative 24 over negative 32. I can tell it's less than 1. So reduce it down. 8 goes into both, so it's 3/4. So it definitely converges. So the formula is quite simple for an infinite sum. So if it's an infinite sum, you start with A1, which is negative 32, over 1 subtract 3/4. So it's like the other formula, but much, much simpler. Put that in your calculator, and it converges to the answer negative 128. So eventually the numbers get so small in this, it doesn't even affect that answer. So it's just getting closer and closer and closer to negative 128. Kind of like a horizontal asymptote. Here, if I find the r, it's negative 6 divided by 2. So the absolute value of that equals 3. It's way too big. It definitely diverges. There is no sum. It goes to infinity. 13, 40 over 200. 40 actually goes in there evenly. It's 1/5. It is convergent. It converges to an answer. And if it's convergent, the simple formula to infinity is A1 over 1 subtract the r, 1/5, and that answer is 250. 14, take any two numbers, so why not take 9 and negative 24? You can tell it's going to converge because it's smaller than 1. Because that reduced down, yeah, negative 3 over 8. So it converges because the absolute value of that is less than 1. And the sum to infinity would be A1, negative 512 over 3, just put parentheses around that, and then 1 subtract negative 38. So just be careful how you type it in. If you do type it in correctly, the fraction would be negative 4,096 over 32. Number 15, it's going from 1 to infinity. The r is equal to 2, so that means it diverges. No sum. It goes to infinity. Here, the r is negative 2 over 7, so that means it converges to an answer, because the absolute value of that is less than 1. So the formula to find that is A1. So if I plug in 1, I get the answer 9. And then 1 subtract negative 2 over 7. Be careful if you type it in the calculator. And the answer is 7. Here again, the r is 1/3, so it converges. So there's a sum to find. So the infinite sum would be, plug in 7. Is that what it says? So if you plug in 7, you get 5 over 2 times 1/3 to the 6th. So use your calculator. 5 over 2 times 1/3 to the 6th. And if you do that properly, you get 5 over 2. And then 1 subtract a third. And that gives you 3.75. r equals negative 4 diverges. No sum. The absolute value of that is bigger than 1. And now let's look at some stories. So Annalie earned interest from her investment account. With the interest earned since opening the account shown in the table below, find the total amount. So that's why we're adding. Annalie will earn after 22 years. So we know we have 22 terms we're going to add up. A1 is 60. What is it going up by? And you can always divide if you don't see it. So 64.80 divided by 60. So if you divide that, you get 1.08. There's your rate. So that's 8% actually, right? So 1.08 to the exponent 22, and then take away 1.08 in the denominator. So her total amount in her account would be $3,327.41. Number 20. Jonas was collecting donations during a football game. He collected $32 in the first minute, $28.80 in the second minute, and $25.92 in the third minute. If this pattern continues, what is the total amount? That's why we're adding the money he'll collect after half of an hour. All right, so half an hour is 30 minutes. First, he collected $32. To find the ratio, you divide. So 28.80 divided by 32. So the R in this case will be 0.9. So it's 0.9 to the exponent 30, and then the denominator is 1 subtract 0.9. So then the total amount would be $306.43. Number 21. A loan payment is made such that the first payment is $5 and each subsequent payment is 10% more than the previous. If the sum of payments made is $3,263, determine the number of loan payments made. So to determine the number of loan payments paid, I need to find n. So the total sum is $3,263. The first payment was 5. 1 subtract the 10% more than the previous one. So that would be 1.10 if it's 10% more. And that's to the exponent n, and then 1 subtract 1.1. Use your calculator to answer it, and you'd see the answer is 44. So if you need a reminder again how you'd use your calculator, you would press solve, and you type 3,263 equals, and then you'd use parentheses, 5 times 1 subtract 1.1 to the exponent x, close it, and then close it again for the numerator, divided by, and then the denominator would just be 1 subtract 1.1, close it, then go comma x, and then close it again, and then you can see it rounds to 44. So what's determine the number of loan payments? So 44 loan payments were made. All right, 22, last one for your homework. On the first swing, a pendulum travels 5 meters, then returns 3.75. On the next swing, the pendulum swings 3.75 backwards, then returns 2.8125. Approximate the total distance the pendulum makes. So you have a situation where it's going forward and a situation where it's going backward. So when it's going forward, the numbers are 5 and 3.75. So 3.75 divided by 5, that's 1 R. So that's 0.75. So one situation would be, as it goes to infinity until it stops moving, the first term is 5, then it's 1 subtract 0.75. Oh, let me do the formula again correctly. 4 divided by 1 subtract 0.75. There's the formula for an infinite sum. And so just going forward, the answer is 20. Going backwards, the numbers would be 3.75 and 2.8125. So 2.8125 divided by 3.75, that ratio is 0.75 as well. Again, the infinite sum, you'd start with your first number, which is 3.75. 1 subtract 0.75. No, again, why did I do that? So, infinite sum, 1 subtract 0.75. So 3.75, that gives you the answer 15. So there's 20 going forward, 15 going back. So if you add those up, the answer is 35 meters. All right, GMath over out. Good job doing your homework.